Alrighty. Sorry, just lost my window. There we go. Hi everyone, I'm Michael Leopard, Senior Practice Manager for Professional Services here at GitLab. And for today's enablement session, we're going to go through using Congregate for air-gapped migration. So this presentation is going to be pretty short, and then we're going to jump into a demo where you can see a couple of terminals and some API calls being made. So the agenda for this session is I'm going to do a quick review of what Congregate is. I'm assuming this should just be a refresher, but for those who haven't used it before, just kind of a quick overview of what it is and how it works. I want to call out some current limitations with our air gap migration support, and then we're going to walk through going through a demo of migrating from one instance to another with no network connectivity in between. So Congregate is a tool maintained by the GitLab professional services team. It orchestrates the end-to-end process of migrating an organization to GitLab through the use of various APIs and our built-in importers. It currently supports migrating from GitLab, Bitbucket, and GitHub, or Bitbucket Server, not Bitbucket Cloud. And we have a couple of different ways we can support migrating GitLab instances, file-based, direct transfer, and air-gap, which is kind of like a addition to our file-based importers and exporters. So Congregate works through these 4 steps. We've kind of 4 major phases of how we migrate data. First, we list from the source. So this is pulling out a snapshot of metadata from the source instance, and it puts them into 3 main types of assets: users, groups, and projects. And that's kind of the initial data transformation from whatever the source instance is to GitLab-friendly syntax, JSON, data structures, all that. And this utilizes the source system's REST API. Once we have the snapshot of metadata, we select specific users, groups, and or projects to stage for a migration. So think of a list as kind of like a git pull, where we get all the necessary data we need, and then think of staging like doing a git add before we commit the changes. And then once we are ready to migrate the specific pieces of data, we go through and kick off a migrate, which contains the migrating stage as well as the post-migration tasks. So the migrate stage is where our built-in importers are utilized, and the post-migration tasks are where Congregate comes in to add additional data through the migration process. So that's things like CI/CD variables, Docker container registries, some of our package registries, merge request approvers, environments, and the full list can be found if you go into the customer folder in the Congregate repository. With air gap migrations, we just focus on those last 2 stages. So this is where it deviates quite a bit from the standard workflow, and we interface with our air gap migration through a bunch of API calls. So the flow of an air gap migration kind of looks like this. So we have 2 GitLab instances, low side and the high side. I'm kind of using, I guess, US government terms here for unclassified versus classified. We set up 2 Congregate containers, one on the low side, one on the high side, and we generate an artifact on the low side. We then send it to the customer's data transfer mechanism. And then on the high side, once that's available, we then import that file from the data transfer mechanism, and then we upload that to the GitLab high side. So where this differs from our file-based exporters is we utilize that as the basis for getting the project. And then after we have generated the export, we create another series of metadata files that store that additional data I called out before, like CI variables and environments, merge request approvers, stuff like that. And then that all gets packaged up into a single tar, and then we just kind of send it off into the ether, whatever the data transfer mechanism is that the customer uses. And the way that we accomplish that, to go a little more in the weeds too, is we use our MongoDB instance that comes packaged with Congregate to act as our kind of fake API endpoint. And so we have a way to switch between making API calls versus making database queries. And that's how we kind of fake the destination API on the source, and how we fake the source API on the destination. Now, in terms of limitations with using this method, it's a one-time transfer. So that means that sometimes there's been discussions with at least US government customers where they would like kind of this continuous sync from the low side to the high side. In its current implementation, basically just a movement from one instance to another without a continuous sync. That's more of a requirement for our product team to address in the future. And that's kind of once they get that working, then we'll incorporate that new mechanism in to Congregate whenever that may happen. I don't know if that's on the roadmap at all at the moment. It's currently limited to projects, so we don't migrate groups like this, and we don't migrate users either. It's mostly just to make sure we can get the repos from one side to the other. It doesn't include the data transfer mechanism as well. So I don't know if any of you have worked with customers either in government agencies or sometimes more sensitive private sector organizations. But what I've experienced in the past is every agency, organization, company does this differently. So instead of us kind of picking a specific solution, we decided to not pick a solution at all and just find a way to integrate it when we're doing the migration like this. Because it could be as simple as they just don't have network connectivity, and we can just like use an S3 bucket to something much more complex that's bespoke to the organization. So we kind of just said, we'll build the artifact, work with a customer to figure out how to move that data, and then we'll just incorporate however they have it set up. And then the last limitation is we don't cover packages or containers at the moment, but that is something we can support in the future. It just is going to, massively bloat the artifact that we generate. But it's something that we could support. It just in the current implementation we don't have that yet. Any questions so far before I kind of jump more into the weeds on how we configure Congregate and running through a migration?
Is this stuff listed in the Congregate docs, Michael?
Like the limitation piece?
Yeah.
I think I call it out in the setup docs, but if not, we can make an MR to update it. I did link in the notes documentation or the notes doc for this this meeting, the setup and usage docs. I'm going to kind of gloss over kind of how we'll get to doing the migration. I'm not going to go step by step in the docs, but yeah, Bomsy, I think we may need to update the documentation to cover those limitations.
Sounds good.
All right, I'm gonna before I stop sharing the browser, I'll show you kind of what the setup looks like. So we have a low side environment, aptly named low side env. We have an example project. It's just like our Spring Boot template. Within it, there's a couple of pieces of extra data that wouldn't normally come over in an export. So that's things like CI/CD variables. So we can see there's just a hello world and a test variable. There is a basic environment that's set up. And then we have a couple of pipelines that are configured, pipeline schedules that are configured. So there's some pipeline schedules, and then within that, there's a couple of variables. So we're going to move all of that data over. And on the high side, this is the location where we're going to move everything to. Just a group called import location. These two other tabs I have open here are Flower dashboards. Flower, for those who have ever dealt with Celery, which is another library in Python. Celery is like a task manager, and Flower is just a UI that visualizes what's in process in the Celery queue. So I'm going to stop sharing my screen for a second as I move over to a terminal, and then we'll walk through that piece. Once I find my iTerm. There it is. You all can see 4 terminal windows.
Yes, we can.
Awesome.
Yep.
Okay, so try to label these a little bit. Hopefully it's not too small. I can try to make the font a little bit bigger, but top left is our low side Congregate node. Top right is our high side Congregate node. Bottom left is the low side GitLab instance, and the bottom right is a high side GitLab instance. Don't worry about the bottom two too much. Really, it's here in the event that I need to like restart GitLab, but it should be okay. It's just, we're just running a GitLab omnibus. So I'm currently sitting in the Congregate node in a Docker Compose file. So if I were to exit it real quick and just run a podman ps, we can see that there's Congregate, Congregate Mongo, and then Redis, and that's how we're going to interface with doing the air gap migrations. For those of you who joined the enablement session on direct transfer, the way we do the air gap migrations and the way we do direct transfer in terms of managing through a job queue is the same kind of process. For those who have not joined, this is how we handle kind of the asynchronous calls. Since there's no direct connection, we basically fire off a job. It processes the export and the artifact creation. And then we do the same thing on the destination where we fire off another job to import the file, which differs from our normal workflow of we have a direct connection. We basically kick off a full migrate and it does all of that in one fell swoop. So going into the Congregate container, I want to just show the configuration changes. So, oops, sorry. So the way that we configure it, it's pretty basic compared to some of our other workflows. So we can see that really we only set a handful of pieces. We set an export section. We specify it's a file system where we're going to download the artifacts. And then we just set the path. This is pretty much default setup. The two important pieces here would be we set air gap to true, which tells Congregate to start utilizing Mongo instead of the API. And then specifically, we say that this node is going to be an air gap export. So that says that when we try to make requests out to the destination, instead we redirect it to storing the data in Mongo. And then just our default specifying Mongo host to Mongo, which is the alias of the MongoDB instance, and Redis is the alias to our Redis instance in the Podman network. And I just disabled SSL verification. In real world, we would not even have the setting. It's just more for the easiness of this demo. And that just pretty much allows us to do data transfers over HTTP, which realistically we would not do in this case. On the high side, the config looks pretty similar. Export section is the same. We do specify a destination host name just to make it easier where we know where we're importing data to. And the way that works is like, it's just so we know that the one Congregate node is associated with a single instance. And then the only other difference here is we have air gap enabled, but then this time we're setting air gap import to true. So what that's saying is when Congregate tries to make an API request to the source instance, it's instead redirecting those data requests to Mongo to make some queries. And that's it for the config piece. So for those of you who have run migrations before, this should look a lot more slimmed down than our other workflows that we support. Okay. I'm going to stop sharing that for a second. I'm going to move into an Insomnia window. I'll show what the payload looks like. There are going to be some tokens on the screen. They will go away in the next day. And also it's limited to just my IP, so hopefully it's relatively safe. Okay, so when we're making a request to Congregate to trigger the air gap export, this is the endpoint is just API / air gap / export. We provide 3 values. That would be the host, the token, and then the project ID. What's important here, and it's called out in the usage docs, is that when we're triggering the export, the token you use in the request is going to be an access token. It's going to be a project level access token. So we run a quick little authentication check where this token is associated with this ID. And if that checks out, then the request will succeed. If not, it's going to fail. And then you're going to need to just generate a project level access token. So I will trigger the export request. And all we're going to see in the response is that it either worked or it didn't, and we'll have a task ID associated with it. If I switch back to my browser, we go into here. This is the same ID we saw before. This is the job that's monitoring what's happening. And we have a success saying that like the whole job finished. So what that meant was it triggered the export, pulled in the extra metadata, and it built out the artifact file. So sorry, I'm going to switch screens again. I'll go back to my terminal. And then if I look in the downloads directory, oh, that's perfect timing. Sweet, it didn't work. You ever have that moment where you run through the demo like 10 times and it works fine, and then you're doing the demonstration and it doesn't work?
I think we would have been more suspicious if it did work correctly on the first time, so
Right?
you're good.
Yeah, you just know that then everybody from PS would be asking you what the hell's wrong when we do it with a customer and it doesn't work.
Yeah, exactly. Interesting. The request made it all the way through. Okay. Well, I was slightly prepared for this to happen. So let me show you what it should look like once the file gets created. This is a little bit of an older file. Sorry, I'm going to switch screens again. Hopefully for the next round, Glenn, this fully works. I was just testing it 20 minutes ago and it was working fine.
Where's the excitement in the minute?
I know, right? Okay, need to find a Finder window. Too many windows open. Or not. Apparently I don't have it. Oh, there it is. All right, so when we generate the artifact, there are going to be two files created. Ignore the pretty.json for a second. Notice that the tar.gz that's included in the artifact, so we do have a nested archive. This is the project export itself that gets created. This is just the standard what comes out of GitLab. And then the project features JSON is the data that we generate that's going to act as that intermediary or the fake API. So I'm going to quickly open up the pretty print version of it. And this was just kind of more for demonstration purposes. And I'm going to switch screens again. I think next time I'm going to just share my full screen. I feel like I've been doing a lot of context switching for you all. And then what that data ends up looking like is this. So that's really small. Let's see if I can zoom in. Okay. With the project ID, we get some details about the project. This is kind of more just for low-level stuff with Congregate to keep the flow going. But we see that we pulled out a project environment. We stored CI variables. We got pipeline schedules. We got pipeline schedule variables associated with different pipelines. And then if there were any approvers, we would have them stored there as well. So I'll have to check those logs in between sessions, but I'm going to move back to Insomnia. We're going to trigger the next request. So where we've gotten to so far is we've configured it on the low side. We've triggered the export. We have the file ready for the customer to send through their data transfer mechanism. Now we're going to move into the high side where the file has made it through the customer's requirements to get it through to a different network. And now we're going to trigger the import for that. So that's another request. This one's a multi-part API request. So instead of it being /airgap/export, it's going to be /airgap/import. And then similar parameters as before, specify the host, the token. In this case, the token can be just a regular personal access token. I don't think a group level access token works. Last time I checked, I think we have a link in our docs to show why that's limited in the file-based import. Then we'll specify the group ID where we want to import it to, and then we're going to specify the file that we'll upload. So to avoid some risk, we're going to use the currently selected file. Hopefully that request goes through. And the import was triggered, which now let me go back to the browser, and then we should be done with the window switching. So if I go back and look at Flower real quick, we can look at our tasks. We can see that one of the tasks was generated, and fingers crossed this makes it all the way through. Hey, it's there. Okay. This is that example Spring project getting imported. We can see the project has been imported in terms of like the standard pieces of data. And to double check that it actually pulled the other data over, this could take a second potentially. So it may not come over immediately, but we do see the hello world variable, the test variable. We can see the environment made it over, and then we can see the schedules as well, and the variables associated with those different schedules. So that's kind of what that'll end up looking like. And then the way that we would track this to troubleshoot some of this is we'll end up, we would dig through some of the logs. I'm not going to bore you all with that. I'll have a better answer for it in the follow-up session that'll also be recorded to call out why the export didn't seem to finish. But yeah, that's kind of the workflow. So the way we've done this for customers recently, I don't know if Petter's on this call or if Mike's on the call, but the way that we've done it is, since it's an API call per project, basically we just write a bash script with a list of IDs. And that's how we'll trigger n number of project exports. And then once we get all that data, move it over to a location that the destination can handle, we will then have a similar type of bash script where we just fire off a series of import requests. So each project export and each project import is an asynchronous job that just gets sent off to a queue to get processed. I haven't been checking the notes doc at all. I'll do that now. Are there any questions? Anything I glossed over that you all want me to kind of double click on?
I have a question for you. Would it, I'm assuming that the answer I should be able is yes, that we should be able to change the project ID.
What do you mean change the project ID?
For example, on the high side, it may conflict with the existing one that's already there.
Oh yeah, when the project gets imported, we'll get a new ID on the high side.
It does, okay.
Down the notes.
Such things is exactly why I always make the suggestion to customers when they're writing their pipelines to not hard code project IDs, especially if they feel like they might be moving environments, you know, whether it be moving to SaaS, moving instances, things like that, because things will break, and recoding it is something that they don't want to do. So I'm just like, if you're going to link to it in a way that, you know, it's by name, right? Like do a URL thing, trigger a pipeline downstream, something like that.
Right.
Yeah, that and like predefined variables also help. There's different ways to have like the dynamic references, but yeah, very important to not hard code IDs between instances. Any other questions?
Also, yeah, can you also restate what it does with the users? Because I think I missed that when you were talking initially.
For users, we assume that the users already exist on the high side.
Thanks.
Yeah, the way that we kind of made that decision initially was the customer we were working with had, I think the way the users were handled on the source and destination were from the low side and high side were a little bit different. And I think they had like LDAP configured on both, so we just were leaning on, they had users already existing on both instances, so we were just going to migrate, like move data across when they needed it. But the way that there's a slightly more I guess complex answer to that sort of. I don't know if I don't think Petter's on the call. He's not, okay. Petter's been going through an air gap migration recently, and one way you can get users over from the source to the destination is the snapshot of users that we pull down when we do a list on the source. You can just copy that user's JSON file to the high side, and that gives you pretty much all the data you need to bring the user over, or at least create the user. There are some limits because kind of a hacky solution at the moment that doesn't include things like SSH keys or user preferences. But there's a way to at least like check, if some additional users at least need to be kind of at least stubbed out on the destination. That's probably way more in-depth answer than you needed. But just
No, it was good because I was, and sometimes there may be a need to map a user from one to another.
yeah, and if the user already exists on the high side and it's the same emails matching, when we do the import, all the attributions should get retained in the process too, as long as the right token is used.
Yeah, that's a scenario I've never seen from moving from high to low where the emails and usernames match. Normally they're always different.
Yeah, and we've run into that sometimes in the past too. And a way we get around that is if the user emails are different on the low side and high side, which does make sense since it's like different networks. If possible, you can add the low side emails as a secondary email, and then when we do the import and user lookup, if it failed on the primary, it should fall back and check the secondary. At
Okay.
least it has done that in the past. Glenn, is that still the case?
I believe it checks all confirmed emails now, so that should still hold true.
All right. Any other questions? Cool. Well, you all can get some time back on this Friday morning, afternoon, evening.
Saturday morning.
Oh, okay. I'm sorry you had to join this call.
Oh, oh no. I mean, it's literally time that I get to book, so it's nothing off my back.
Okay. All right, cool. Awesome. Okay, then I think we're all good for this. You'll get some time back in your day. Thanks for joining, and let me know if you have any other questions. If you all are on our Slack, feel free to ping me with any questions you got. Thanks, everybody.
Thanks.
Thanks, bud.
Good.
See y'all later.
Thanks very much. Ciao.
Here you go. Take it away, Michael.
All right, thanks, Glenn. So hi, everyone. I'm Michael Leopard. I'm Senior Practice Manager here at GitLab, and today we're going to be going through using Congregate for air-gapped migrations. So let's share the screen. Y'all see the whole window?
Yes, we can.
Awesome. Thank you. Yep, so we're going to go through a quick slide deck, and then I'm going to walk through the demo of how we will use Congregate to handle air-gapped migrations. I don't know if I covered this in the last session, but is everyone aware of what the term air-gapped means with in terms of like systems? Cool. I'm going to take that as a yes, but I will do a quick refresher. It basically just means the two systems that need to connect to each other there's a sever between the two, so they're completely separated. Usually, a common example of this is if we look at U.S. government unclassified versus classified networks. There's usually like a physical disconnect between the two networks where you can't automatically connect between the two, and you need some kind of a data transfer mechanism in the process. So with that being said, this is the quick agenda for the slide deck. So we're going to do a quick refresher on what Congregate is for those of you who haven't used the tool before. I'm going to talk about how Congregate works normally and how it works for the air gap migration piece. I'm going to talk about limitations with the current air gap migration implementation, and then we're going to walk through migrating data from one GitLab instance to another through a mocked air gap setup. So Congregate is a tool maintained by the GitLab professional services team, and it orchestrates the end-to-end process of migrating an organization to GitLab through the use of various APIs and our built-in importers. So it currently supports migrating from GitHub, Bitbucket Server, and GitLab to GitLab, and then we leverage our built-in importers that our import team and product have created and maintained, and then we add some additional data on top that the importers don't cover. So the way this all works is there's 4 stages to a Congregate migration. The first step is listing. So we run a command called congregate list that pulls down a snapshot of the metadata from the source instance, and it then puts that into 3 main types of assets. So that'd be user data, group data, and project data, users, groups, and projects. We stick to the GitLab nomenclature for this. So while we're pulling data from a source like GitHub or Bitbucket, we're doing a data translation and transformation in the process before we get it to the expected data structure we need when we're getting prepped to migrate the data to GitLab. Once we have the snapshot of the metadata, we select specific users, groups, and projects to stage for the migration. So think of a list as like a git pull, where we pull down data, and think of staging kind of like git add if you're adding changes to a repository, but you haven't yet committed the changes. So once we have all the necessary data staged for the migration, we go ahead and start migrating the data. This would be kicked off through the congregate migrate command. And this is the stage where our built-in importers get utilized. Now, when we call a congregate migrate, we are also doing both the migrate step and the post-migration tasks in series. So we use our built-in importers, import the data, and then once we have the majority of the data there, we run post-migration tasks for that user, group, or project to add additional data to those assets. So for users, that would be things like SSH keys and user preferences. For groups, that would be like variables. And then some examples with the projects here would be CI/CD variables, Docker container registries, some package registries, merge request approvers, and environments. And the full list can be found in our features matrix, which is located in the customer folder in the Congregate repository. So when we're dealing with an air gap migration right now, we just are focusing on those last 2 steps. And that is due to just the current mechanism for how it's functioning. When we look at the workflow for how an air gap migration goes, we would have the 2 GitLab instances. We'd set up 2 congregate nodes, which in a situation where we have direct connection between the 2 instances, we just actually have 1 single node connected to both. We have to have 2 separate ones since they cannot speak to each other. The 2 GitLab instances can't communicate with each other. And so we can pull the data from the low side onto the congregate node, generate the artifact we need to move up to the high side. We create an artifact file, and then we go through some form of data transfer mechanism, which then moves that artifact to the high side network. And then on the high side, we have another container that's configured to import data into a GitLab instance. And the way that works is we have we use our built-in file-based exporter to generate the project export, and then we pull in extra data from the API, store it into Mongo temporarily, build out a metadata file, store that within an archive, and then that whole bundled archive gets sent up to the high side. And on the high side, what we do is we extract the archive file, import the project through our file-based importer, and then we reference that metadata file that we generated on the low side to repopulate the data on the high side. Effectively, to go 1 level deeper, we're utilizing the MongoDB instance that comes packaged with Congregate to act as a API replacement for each node. So on the low side, we're using Mongo to act as the high side or as the destination endpoint. So instead of us making post requests to update data on the high side, we're just on the destination. We are just storing the data in Mongo. And then when we get to the destination, we're using Mongo as our source location so we can retrieve additional data. So in terms of current migration limitations, so the way it's currently set up, we are limited to just a one-time transfer. So that's standard practice for doing like a data migration itself. It's not necessarily usable for a continuous sync. That's probably more of a feature improvement we would need on the product side that we would then integrate into Congregate, not the other way around. Our air-gap migration is limited right now to projects only. So we don't support migrating users out of the box through the air-gap migration process. Although in the previous session, we talked about kind of a way to get around that. And groups are just excluded entirely in this situation. It doesn't include the data transfer mechanism, and that's based on kind of just previous experience working in highly controlled environments where the data transfer mechanism tends to be different for different organizations, where sometimes it's a fairly robust transfer mechanism with heavy compliance rules, and you can kind of effectively just upload a file and let it run a scan, to as old school as like you burn something to a CD and walk it to another office, right? So we didn't really want to take a strong opinion on that. So we want to make it so we have the artifact that's easily consumable. And then we would just work with a customer during the engagement to kind of wire up that data transfer mechanism into the process. And at the moment as well, no packages or containers are included. So we could support that in the future. It's just going to heavily increase the size of the archives that we need to transfer. Any questions so far before I jump into the demo? By the way, in the notes doc, there is the link to this slide deck as well as the link to the setup that we're going to kind of briefly go through, as well as the usage that I'll be demonstrating soon. So if you want to follow along there, you can. All right, so let's move into the demo process. So if we can see in the browser, I've got the example low side environment, and we're going to migrate this example Spring project. So this is just using one of our standard project templates. And I added some extra data to it that our file-based exporter doesn't include by default. So that would be things like environments. There's just a very basic environment stored here. I've got a couple of pipeline schedules along with some variables. And then I've got a couple of CI variables included as well. And then on the high side, that is just another group on another instance. And then we're going to kind of monitor the data transfer process here. The other two tabs here are, they are extra UIs that get bundled into a Congregate container. This is a tool called Flower. So Flower is a component of the job queue mechanism we have in Congregate now called Celery. This is just going to help show like what has been processed as we send API requests to export and import projects. So there's just a Flower instance on the low side, Flower instance on the high side. Okay, next I will open up iTerm. So in these terminals, top left is the low side Congregate. Can you all still see my screen? I think I have the Zoom. I don't normally do a full screen share.
Yeah, we can
you all
still see your
this everyone?
screen.
Awesome. Okay. So on the top left, there is the low side Congregate instance. On the top right, there's the high side Congregate instance. Bottom left, bottom right are our GitLab instances as well. So what I want to show in the terminal is just kind of what our configurations look like. So I'll open those up. For those of you who have gone through a standard CLI-based Congregate migration, these config files should look pretty small in comparison. So on the low side, we really just care about setting the export location. That's where we are exporting the data to once we trigger the request, and where we would wire up to a data transfer mechanism, or where we know we need to like SCP data out. And then the most important pieces of the config would be these two lines here, which is the air gap setting and air gap export. So once we set air gap to true in the config, that's saying, hey, now we need to redirect some of the data instead of to source or destination when you start redirecting it to Mongo. And then we are setting the low side instance to air gap export, meaning the data that we would usually send out to the destination is now going to get funneled into Mongo instead. And then the other pieces are just pointing to the Mongo and Redis instances in the Podman network, and then SSL verify. It's really just something I'm doing for the sake of the demo. Usually, you should leave it set to true. That's just allowing us to transfer data through HTTP for the sake of this demo. And on the high side, we have an extra section for the destination where we are specifying where we're going to be importing data to. And then it's pretty much the same with the exception of we're treating this node as the air gap import node instead. So what that means is anytime we want to try to make a request to a source instance, instead of us trying to reach out through HTTP, we're making queries to Mongo instead. And the rest is pretty much the same. Okay. And now to get this all to work. Sorry, I think Insomnia probably might have the lowest font. I was trying to get to zoom in, and I would use it a little bit differently. Okay. Doesn't have the same keyboard shortcuts as the other apps. So there are some tokens here. They're going to go away soon. And this is limited to my IP. So I don't know if you all want to pull some data, by all means, I guess. But the way we make the API request, we make an API call post request to the low side. With an endpoint of API/airgap/export, and we specify three things: the host, where we're pulling the data from, the token that we're going to use to authenticate, and then the project ID. This token needs to be a project level access token that's associated with the ID that we are specifying in the request. Personal access token will not work in this case. Neither will a group access token or an admin token, anything like that. It has to be a project access token to handle the authentication. The reason for this is in the event that we want to set up kind of a self-service low side export for different teams in an organization to consistently send data to. This allows it so the token that's provided to Congregate is specific to the project itself, instead of having one shared token that like has the risk of getting leaked or something. So I'll make the request to fire that off. You see the export's been triggered. You can also see the previous export where I was verifying that this would work. I'm going to go into Flower on this side and look at the tasks. The number was 8277. That says it's a success. I'll believe it when I see it. And there it is. So when we create the export, two files get created. So the first one, that to-move example spring.targz, that is the base export file that gets generated from our project exporter. And then the underscore artifact is that same targz above, packaged inside another artifact or inside another archive, as well as all the project features. So what that ends up creating is a JSON file. I'll just show what that looks like. Creates these two files inside of it. And I'm going to show what the project features looks like as well. So inside project features is some metadata that would be just the ID on the source. This doesn't transfer over. It's just more for Congregate to know kind of what the source looks like. And we can see some of those additional pieces of data like the environments, the CI variables, pipeline schedules, the schedule variables, and then if we had any merge request approvers or project approvers, they would also be included as well. So we have all that created and generated, and now I'll go back to Insomnia, and we're going to trigger the high side import. So same thing, we're going to do a post request to a /import endpoint. The payload looks pretty similar. We need to do a host, a token. A token in this case can be a personal access token. I don't think a group access token works at the moment. Our docs cover the link as to why it's a limitation of our importer. So you're going to need to use a personal access token or an admin token, something like that. We'll specify the group we're importing it to, and then we're going to upload the file. So this is just an old copy of what was downloaded before, and I'm pointing to the high side, the environment for the host. So it triggers the import, and then we look at Flower, we can see this task has been created. It's still running. And then if I go into the import location on the high side example, we can see the new project just showed up. And it looks the same as on the source. And it might take a second for everything to come over, but I'll just check. So pipeline schedules are here. We'll see if the variables came over yet. They're here. Check for the environments, which is also present. And then the CI/CD variables. When I click the right button, there it is. And then there's the two variables there. So we're to compare it back to the source. I'm gonna look at like settings, for example. See hello and test. There's hello and test. And the same with all the pipeline schedules. So I'm also realizing I have like dark mode and light mode, so apologies for the flash of brightness and darkness there. Better for me to just differentiate as I was testing it out. And yeah, that's pretty much it. So we can see the data came over. And this was pulling that extra data from that project features file, ingesting it into Mongo, and then using that to query instead of making the API calls. So that's pretty much it. Are there any questions after seeing the process in real time? Cool. I've put you all in awe.
I do have one question.
Mhm.
The both containers can be run on one virtual machine?
No, they'd be two. You'd have a separate virtual machine depending on the way the network is set up. So if we look here, the low side, this would be its own network, and then the high side would be its own network. So you would have a VM with a Congregate container running here on the source. You'd have a separate VM and container running on the other network for the destination. And then you'd configure the two nodes separately. I just had it all together in like one terminal just to show just all the points connected together. But in a realistic situation, you'd probably be looking at just the low side at first, get all the data exported, move it into that data transfer piece, and then you'd go like to another location for the high side import.
And you say the data transfer part is in MongoDB.
The
Right.
data transfer part is dependent on the customer. So like once we make that archive file that was in the terminal, like so once we generate this file, we send this to some other location. So for the sake of this demo, I just put it on my MacBook. But in a realistic use case, we would download them all down to some other location. It could be just like an S3 bucket. It could be a specific encrypted data storage location that the customer has. It just depends on what the organization uses for secure file transfers when they have to move data between a less sensitive to a more sensitive network.
And then the higher side will, how they can get the package.
So on the high side, then once we have that data transfer mechanism like wired into the process, we would then either connect to that location directly from the container or the VM, or we would pull those images down through like an SCP command so that we can then import them from the Congregate node. Actually, we don't even have to do that entirely because we can upload that through like Insomnia. Basically, as long as there's a place that we can upload the data to. So if I'm making the request through Insomnia, I can just specify a file either from wherever I'm running it. If I want to make a curl request to the Congregate node from whatever has access to those artifacts, yeah, we can make the request at that point.
I think the part I'm confused is that on the lower side, we have this package, right? Like in general, we download it to like a download folder. And then we have to put this package somewhere so that on the higher side, the Congregate can grab, I assume that the Congregate can get that package and then import. It's just like how they share the package. I don't know if that makes sense. Like if, like say, I will understand if say the lower side, we have this package, we upload it to S3. And the higher side, we download it from S3 and then like do the process like import. Does it like, is that how it works or my
Yeah, that's the
understanding?
way that you could do it.
Okay, so they just have the customer need to provide some location to store the package for us to either to upload it and download it.
Yep. Yeah, exactly. And
Oh,
so what I've seen in the past with working in like different US government agencies is sometimes there's like a portal mechanism, sometimes there's like a secure file upload. There's a tool that AWS offers for GovCloud called Diode that has its own mechanism. And I have worked with some government agencies before where like I am burning to a CD and walking it to another building. So that's kind of why we just left the data transfer up to however the customer has it, because chances are when we're doing something like this, the customer already has a process in place. But yeah, your S3 example is a great example of like how that would pretty much work. S3 being that middle piece.
okay. And this is more for migration from self-management to self-management or including
Yeah, it's
GitLab.com?
self-managed to self-managed. I think I've actually seen someone do this. Petter's not on this call. Petter's been doing something similar has been using our air gap migration, but I think he's been doing it I think he's done it for a .com migration. Glenn, do you know, have you been keeping track of any of that? I forget I won't say the customer name, but I forget. He's working on an air gap migration that I think is actually trying to do a migration to .com. But there's like
I have not seen that.
okay, I might be misspeaking then. Petter's working on one that's a little bit different than I originally expected when we rolled this out. But yeah, Nikki, usually this is self-managed to self-managed.
Okay. Got it. Thank you.
Any other questions?
Okay, looks good. Don't see any in chat or comments in doc. So thanks, Michael, once again for putting that on. I appreciate it.
Yep, no problem.
All right,
And
everyone have a
any
great
questions
weekend.
as this goes through, just let me know.
Cool. Yeah, just send out questions. Any questions, reach out to myself or to Michael and let us know. Otherwise, everyone have a great weekend. For those of us heading to Summit, safe flights. See you there sometime Monday.
So
Take care all.
Everyone.
Thank you. Have a good weekend.
Take care.